Alright, draft physics video. Been a bit behind in getting this one done. But anyway, just thought I'd go through an overview and just see how that goes. Not well constructed in my head necessarily, and that's probably not a good idea, but, you know, it's all good fun, right? Just kind of thought I'd go over the general principles. So we have this idea of matter. Matter would be when you take this stuff, which is going to be called the field, and you consolidate it into densities, thicknesses of just one kind or the other. So these could be protons, this would be electrons. These would be the plus and the minus part, the electrical part of the universe, in the sense that it's a collection of the compression of this field stuff. So it can be logically understood that if this gets compressed, then this gets expanded, and likewise for both entities. And so that would be the nature of matter, is just a consolidation and compression of this field stuff. Force, okay, now that would be what travels through fields. So if we call this the field of the entire universe, just pretend there's a lot more arrows. Force would be changes, either expansions or either compressions or expansions within that arrangement. So it would be bits that have, more or less densities in specific areas, traveling in specific directions. And that's sort of the key to this thing, is that you can, through this material compression, change the thickness of the force in this field. And so it's basically more of one color arrow or less of another one color arrow going in a specific direction would be what we call energy. Obviously, these bits would be energy because they have the ability to release a lot of force or intensity in specific directions. And in terms of expansions or contractions or compressions in the field. So some people make a lot of hay out of the fact that physics doesn't really define the character of the fields in physics, and part of that is because they have gone with the Einsteinian perception of bending space rather than having something in the space that is contracted and expanded. So I would argue that I suppose string theory, as much as I don't like the name of it, or what conceptually it's been allowed to create, yeah, I guess I'll draw it. Just because it's worth explaining, I suppose. So you could have two pieces of this matter stuff at some distance from each other, and you could first understand that to create these things, you had to take something out of what was between them to make them. So if there was 20 little things, there could only be 10 because they have consolidated the other 10. But you could also understand that between any 2 points in space, even billions of light years distant, like a photon that's 10 billion light years from here, and in 10 billion light years it'll arrive here, and there's nothing apparently in its way, that photon represents a path, and that path is can be understood to be sort of compressible, in the sense that if you understand that each one of these things is going in a direction, could be either way, but it doesn't really matter, and if you understood them to be reflecting off these consolidations, then you could understand if I bring them closer together at half the distance, that I'm going to have a lot more reflections because they're going to keep bouncing off of each other. And so the frequency of these impacts will increase. And so there'll be a natural tension between things that would be created, where the closer they get, the more pressure that exists between them. And the further away they get, the more tendency there is for there to likely be more field outside them than inside between them, and they're going to be propelled towards each other, so to speak. But that's for the material body. So again, you have to understand that these are compressions, and that these arrows don't bother each other at all. They go right through each other. The force elements go right through each other. And it's only when they interact with these denser elements that they're reflected. But in that sense, string theory can be understood as there's only so much stuff between two things. And if you bring two things together across the universe, so if I take a sun 1 billion light years away and I start bringing it towards our sun, the stuff between our sun and the other sun is going to become compressed in the sense that it will make its trip back and forth and reflect more frequently, and so it'll create more pressure. So then you get this sort of the understanding that it's the absence or creation of pressure in between things that is creating what we call the reason for things to move towards each other. So the Einstein picture takes away all of these force elements and just creates the idea of the compression field as a funnel that everything falls into. But it doesn't give any it's a clearly a pull convergence. Everything is pulled in. There's not any force on the exterior that's pushing them in. So this model of the material reality is, by creating a compression here, you created an expansion somewhere else, and that expansion is essentially something things fall into, in the sense they're pushed into them by the normal pressure. So high pressure here ends up with low pressure here, ends up with high pressure out here, in the sense that this was another body here. You could just sort of understand that the difference is going to have high pressure here, you're going to have high pressure here, and you're going to have an absence of pressure here, except as you move these two things closer to each other, you'll have an increased pressure, in the sense that whatever's between them is now compressed, because these aren't going in, they're reflecting off. So that's the difference between the Einstein model. Einstein's model keeps sucking stuff in and doesn't explain how it goes out, where this model explains that it does in fact go out. It reflects. But in acceleration it's getting absorbed. So yeah, once you start getting into the consumption of the bits, then it all starts to get a little bit confusing. So let me just try to go with these more simple ideas. So if you take that field and you just think about what this field really represents, is there's only a certain, if I picked a point in space, some arrows are pointing right at that point. They will hit it, and most of the arrows won't have anything to do with it. So obviously the relevancy is only going to be the arrows that are going to hit it, and every arrow that's going to hit it is going to look like it's heading right for it. Now the trick is that there's two actions that can happen to a material body. First off, is made of both protons and electrons. So you have both the blue and the green objects in the matter, and so that their interactions are sort of neutralized in the end, and what you end up with is a thing held in space, and it just depends on whether it has an extra compressed force coming at it, or whether it has an expanded, I don't know how exactly to draw expanded space, but expanded space would be something it would move into. Compressed space would be something that would push it. And yeah, so I don't know if that's incredibly helpful, but you just get the idea that everything's heading right for this thing, and what it's essentially doing is it's reflecting everything that comes in, basically has to go out. There's a conservation, and if the object moves, then that essentially equals a consumption. So if this object moves this way, it means it consumed an extra compression. That means there was an extra arrow here that compressed into this matter, and now it has more arrows going this way and less going the opposite way, or one of the perpendicular directions. So I guess that could be best illustrated with, so this would be the gravitational model in its simplest form, is that as the two objects move towards each other, in spite of the fact that there's more bouncing back and forth between them, more obvious is the fact that the vectors of all this force can't get to each other, and you end up with a low pressure in the middle and high pressure on the outside. But it has more to do with the fact of what's happening inside of those objects. I really didn't want to get into this, but we're going to kind of have to. That's where I ended up going. So that's what we'll do. I suppose it's kind of a it's the theme is that all of this, in regular physics, is explained by non-physical forces and fields of virtual things, and of space constructs that can be expanded and contracted. And so there's nothing physical in regular physics except for perhaps the matter and perhaps the elements of compression. But there's no explanation of what that compression is made out of, because it doesn't really explain it as being a field of energy. It's just explained as a field of some sort of virtual, the idea of it, but not the realness of it. And they just change everything into a probability equation. And so the probability part gets into this because there's two basic functions. Let's say you're an electron. We'll make the electrons blue just for the hell of it. So you could understand that there's the blue arrows that are in the field would have a certain effect. And the idea is that the blue arrows merely do the reflecting thing. That is, they hit, they bounce off, and the energy, is felt in the sense that they gain a little bit of pressure in this direction. What's happening when an electron gets hit by, so it's a head-on collision. So the point is that this thing, when it's stationary, has stuff going in both directions, and the field is basically hitting the stuff head-on that's trying to go out. So the stuff trying to get away is hit, it's knocked the other way, and then this force on this side hits it back and hits it back and hits it back. So obviously it's just trapped inside of this from all these directions, and that's essentially the function of the blue arrow. So an extra blue arrow, if I was to add more energy, compression in the field coming in, that compression would be realized as a little extra bit held in here going this way, and it would release a little bit going this way or this way. Extra bit. But more to the point, so that's what the blue arrows do. They're basically holding the shape of the electron or the proton. So the proton would be the opposite scenario, would be all in green. So, but the green arrows, so we'd say the plus force or whatever we want to call it, they do something different. So when they come in, they don't hit head on with anything. They only hit perpendiculars. So the perpendicular elements moving back and forth this way get hit, and the green arrow, instead of reflecting back, is shot perpendicularly. So the green goes perpendicular, and what essentially happens is an arrow going this way ends up going this way inside here, but it's a blue arrow. So it basically turns a blue from going left to right to a blue going forward and back. Obviously forward in this case, forward this way. And the direction of the electron, say this was an electron, ironically, because it's going to lose an arrow, and so it's going to end up creating an imbalance going this way or this way. And depending on how many arrows were going one way or the other way, and depending on which side it hit, it'll end up with its next location in this direction rather than in this direction. Because when it hits the perpendicular, it creates an imbalance. And I mean, so, or it could be this direction. Or if it's fixing an imbalance, it could be straight ahead. So if there's already an imbalance in the electron, then it'll make it go straight. But that's why electrons move so erratically, is that when they have this force comes in, they tend to have the option that they'll move in any one of those three directions, depending on the balance of which way they already were imbalanced. So if they were perfectly balanced, then it hit the left side, then it will move to the right. If it, I mean, you could sort of figure that out, I think. But anyway, that's where it gets kind of complicated, because as they turn, essentially, then they start having more force in different vectors. But anyway, that I won't get into all that. So that's part of the reason why they can't really hit each other, is because they're also turning. As they get closer to each other, they end up turning. But I won't even get into that. It's quite complicated. So you can understand how complicated it gets. So you have two different ways that they interact. So the same color on a proton is only doing this, where it's doing the reflection thing. And if it's a different color, it's doing the perpendicular thing. So the force comes in one way, it leaves perpendicular, and this thing moves something like that. And vice versa. And so it's the combination of those two things that create essentially this idea that when these things accelerate, so when you accelerate an electron or a proton, as you give it more momentum in a direction, it's going to release the extra in the perpendicular directions. And then when you decelerate it, that is, when you take away that imbalance, what you're essentially doing is cutting this off, and then you'll end up doing exactly the opposite in a sense. You'll create a headline, the force will be released in the direction of your movement. So if you're moving this way and you decelerate, you'll release force ahead of you, and when you're accelerating, you'll release force perpendicular to your acceleration. So how that would be relevant in like a conductor, wire or something, is that if there was force coming in and an electron had gained some acceleration in a direction, as it lost that acceleration through the fact that force will take it away, but as it loses that acceleration, what it's essentially going to do is it's going to give the force to the field in front of it. So the electron ahead of it is going to be hit with that extra and be pushed in there. So it basically conserves by decelerating forward. It just kind of means that as this if there was energy coming in generally this direction, the acceleration would happen, and these are in different colors, so so I'm just confusing things by using the same color. But anyway, so you would be giving the EMF off perpendicularly as you're accelerating, and then when you're decelerating, you'd be giving all the force back to the direction of the force. So essentially you can see that as one electron stops, the one forward of it moves, and then as this one stops, the one forward of it moves. So the force moves through the electrons, and so the electrons essentially are kind of rolling through the force in the sense that they don't individually go the whole course. They just move part of the course, release their energy, and then that forces the next electron to move, to accelerate, to move, and do the same thing. Accelerate, create the EMF, then release the force ahead of it as it decelerates. So that sort of explains why there's why you're basically converting not necessarily straight line. I mean, it's straight line force, but it's not straight to the elements you're moving. But the elements you're moving are straight, and so it essentially focuses all of this energy, ends up getting focused in one direction, ends up getting converted essentially into movement in one direction. And that's sort of the whole theme here, is that these simple functions sort of create the idea of taking force from various directions and converting them into a release of force in one direction based on how you would arrange, how the electrons are arranged around the proton, would end up creating definite strong and weak, compressed and expanded points in the field, mostly. So anyway, but yeah, it does get a little bit complicated, so I guess I'll try this one more drawing. Just try it, see how it goes. Because it gets quite complicated figuring out the repulsion and attraction between protons and electrons. Really complicated, actually, because the difference in how their forces are affecting them. So I'll try to do this as a step at a time. So here you have two electrons, let's say. And as I pointed out, you can sort of understand as they get closer together, they're compressing the amount of stuff between them. So there's now more reflections taking place, and that's kind of an obvious repulsive force that's keeping the two electrons from getting near each other. And then you have the proton, say, that's out here. And what's happening with its force is whatever, so again it's back to this, these are straight line reflections, where in any force coming off of this in the green form ends up leaving this way. So there's no, it doesn't reflect back. So you can see that there's no, without the reflection, then there's no increase in the pressure between the proton and the electron. So now any external pressure would be stronger, more greens out here, when it increasing the pressure, relatively speaking. There'd be less pressure in here because all the pressure in here is ending up leaving perpendicularly. So it's like it lets the pressure out. So the compression leaves through the perpendicular EMF of the momentary acceleration, and even though the acceleration's in the wrong direction, the point is it's coming back, because of the lack of a reflection, and the lower pressure, and the same is happening to obviously anything coming into the greens from the blues are doing the same thing, in the sense that any blue energy is leaving through the perpendicular, and there's no reflections. So anything coming in here that's blue doesn't reflect back to hit this blue. Instead it leaves in the perpendicular direction. So in a sense there's no way for the blue energy to get back to the blue. and there's no way for green energy to get back to the green. It'll always end up going through the perpendicular. And so the force that's these, so this is the accelerating force. So when you're doing the perpendicular thing, that's acceleration, and the deceleration is also a perpendicular exchange, in the sense that as you gain acceleration, it means you've got more stuff going one way than the other way. And so obviously any stuff coming in this way will more likely hit this than hit this, in the sense of create a conversion, where it's going to change this into more this way, and so you lose this. So this leaves, and this becomes an add-on to what's called the electron or the proton. That's why they're constantly decelerate. So anytime they get acceleration, they automatically lose it, in terms of the field will take away their acceleration and turn into a deceleration. So when they accelerate, they emit force sideways, and as they decelerate, they emit the force forward. And that's basically the compression, let's say compression. And obviously when there's an expansion, I have to try to fix the word, I have to find a better word, I suppose, because an expansion would just mean an absence of one of these, an absence of pressure. So it's an automatic that if I have an expansion in the field coming towards this, and then I have coming this way a compression, it's kind of obvious which way this thing's going to end up going after this time period is completed, because it's going to have 4 things hitting it this way and only 3 things hitting it this way, which is going to mean it's going to go that way. It's going to spread this direction over this whole thing. Obviously it's not going to go as fast as this that way, but it will gain acceleration in that direction. So an expansion is so if this was normal field pressure, and the expansion would mean that there's less than normal field pressure. So that's the kind of the tricky bit, is that you have to recognize that the less than, which is basically what's going to be, there was no, it's too hard to draw these are just the compressions in this drawing, but for every one of the compression arrows there's an expansion arrow, an expansion 0, and those are automatically also conducive to normal field pressure, then becomes high pressure relative to the absent pressure here. So you have this was a consumed bit here. I don't know what the hell that was about. So these are real arrows, and this is a naught, and the naught is obviously less than a real arrow, less than a real influence, say it that way. Alright, well, I'm probably in deeper than I wanted to get, but you can see that yes, it's getting kind of complicated. And so yeah, I was hoping I could get my computer model together and start doing it, but it's I still have to get, there's a lot of there's a lot going on, even though it's a very simple mechanism. This idea of perpendicular energy releases versus pure reflections, and the difference between acceleration and deceleration in terms of which way the energy ends up going, the compression and the expansion in the field. So, but that's sort of the theme anyway. It's the general idea, just to get the idea that it's just replacing ideas like bent space and strings with actual quanta, actual things that are either dense or sparse. So as I make them more dense and make them more sparse, you can sort of understand that that's going to change how these things will move in that field based on how dense, how many arrows are coming from one direction versus the other direction. And it's kind of that simple. And that there's inevitably expansions in this field from the creations of these compressions. So the existence of matter essentially creates the noise or the activity in the field that's going to keep jiggling the matter. It's created imbalances in the field that are still moving through the field. So the imbalance is created by the very creation of the material compressions and segregations essentially dictates the fact that there have to be expansions moving through the field, and those are constantly causing everything to vibrate, essentially. And obviously with vibrations you can have things called frequencies, and sort of game on for the idea of the moving compression in a field, or the moving expansion or not in the field. And that's what appears like a wave, but it's not a wave, it's actual stuff moving, either compressed or expanded. Much like a water wave. You could argue that the peak of the wave is a higher density of water, greater mass, and the trough is the absence of mass, the absence of, a knot. And so you're going with an extra, more wave, more water at the peak, and less water at the trough than the general field. And that's why it functions a lot like that, is because basically that's what's going to happen in no matter what you make this field out of. Like I said, I don't think, obviously I'd say bent space misses, and it can't be unified. Number one, it can't be brought down to the electron and the proton, and so it's useless for that reason. But the more useless part is the idea that it's a convergence with no output. It's a vacuum cleaner without an exhaust. So it's an endless supply of energy with no explanation for where the energy came from, where this active field creates the energy for gravity. And so you don't have to rely on a bent space. It's the external pressure creates the energy for the attractive force of gravity. And string theory, obviously the idea of connecting them with literal stretching rubber bands, it might make mathematical sense. It might be a way of describing compression and expansion, but it's, in my opinion, a lot more reasonable to understand that as being more density and less density, more volume or less volume of the arrows. Now the reason why these are different colors is to really get to the polarization thing, the idea of magnetism, because this is what makes magnetism work, is the fact that the proton and the electron emit a recognizably different force, and it matters which force is affecting something. Well, and what it's made out of predominantly will decide how it will move in that force. Yeah. Alright, probably enough of a video. Probably not as I wanted to make something simpler, and it just ended up being complicated. But I just wanted to deal with these words, that they're not that complicated. Matter is just the collection of these little dense bits, these little thick higher volume pieces of space where more arrows are smashed in. Force is just when bits are released, when compression is released or expansion is created by the absorption of arrows into something goes in, it doesn't come out until this releases it, in terms of this stopping, this decelerating. So if it goes in, it accelerates in the direction it went in, and until it releases it, it maintains that acceleration, obviously. So and so there's an absence of the force that was here, doesn't go forward, technically. You sort of understand that. So force is just imbalances in the field, and energy is essentially just that's what force is. Energy is just the idea that there's the expansion and the thick density and the thin density create an obvious imbalance, and energy just exists wherever that imbalance exists. So if you have a lot of imbalance, you have a lot of potential energy. And compression and expansion is just a way of saying more volume, less volume, or more density and less density than what would be a neutral field. Yeah, okay. Alright, well, till next time, I'll work on it some more and see if I can get it a little simpler in terms of making this yeah, more understandable, just because it's like there's 4 rules, but when they're actually interacting with each other, what's the pluses and what the minuses are gets a little hard to keep track of in a mechanical drawing. Obviously I can't make this drawing evolve. Like this happens and that causes this to happen, and then that causes this to happen, and that causes that to happen. It's a little complicated to do all of that without ending up with 43,000 drawings. Anyway, okay, that's enough, I think. Till the next time, and such. I haven't done a room in a while. Maybe I'll try to do that. Yeah, sometimes soon or something. Maybe, I don't know. See if there's somebody. There's a couple of people who claim they wish to debate, but I don't know if they really do. I think they just wish to be rude, but we'll see.